Hi, Professor. Hi, dear. So this is the video. This is the video related to the cloud formation template that we are going to use to set up our infrastructure. So this first template. So we have 5 templates. So first template is about the IAM user and the group policies that we need to have to access the resources that we will be using in our project. So this is the template for the IAM user. So what we have done is in this template is like we have created a user inside a group that is related to admin, and we have assigned some initial policies to that user so that he can use the CloudFront template. Plus, he can use some of the resources, some of the basic resources that is needed to set up the CloudFront run the CloudFormation templates. So with like this is the same template. And with the same template, I have created this cloud project user. When I go to IAM user here, so this is a user that is created with this cloud project user. Now I'm going to run this CloudFormation template again, and I will again create a user with it. So let's upload the CloudFormation template for IAM user and group and policies. I'm going to keep it as cloud IAM user, and password will be maybe password @1234. And let's initiate this template. And this acknowledgement comes whenever we are using the group and policies or roles. So we have started the creation of the stack. By the time we are creating a user, let's create, so what happens with this user is like this user will help us to get the this AWS access key ID and the AWS secret key that we'll be placing in the secret manager. And we will be using it to access the Dynamodb resources and the S3 resources from our code. Now, I have already created a cloud project user just to speed up the developments, just to speed up the video that we are showing. So this user will be created on the backend. Now, let's create the VPC and the EC2 that is our backbone of our system. So what happens with what we require in VPC is like, with VPC, we require 3 public subnets. In these 3 public subnets, we have 3 EC2 placed. So first EC2 will be used by the React app, that is a front-end app that will call the API gateway, and then API gateway will channelize the request to other 2 EC2s. So if the request is for the seller API, it will go to EC2 seller, and if it is for the ordering of any product, so it will go to product EC2. So we have 3 EC2 basically here. And apart from this, we have assigned some EIPs to them, and we have set some default EC2 type. So it is T2 small. So these are the mappings that is used for the architecture level at the T2. And these are the regions that we have initially used. Resources. Now we are going to create a VPC resource, 3 public subnets, 2 private subnets. In these 2 private subnets, our Dynamodb will be placed. So this will have Dynamodb table orders, and this will have Dynamodb products. Now we have an internet gateway to have a connectivity to the internet, to the public cloud. Now this is the internet, we are attaching the gateway. This is a route table for the public routes and for the public subnets. This is a second route table, and this is a third route table. Now these are the ports that we need to get open for the for accessing the EC2. So 80 port number is open, 22 is open for the SSH one, and 80 is open for the HTTP connections, 443 is for the HTTPS connections. Now we have assigned 3 elastic IPs, EIP1, EIP2, and EIP3. And in the end, we have created 3 web server instances, 1, 2, and this is 3. So let's upload into the so this is the cloud I am user that is created in the backend. Now when we go and we can see this third user is already created. So this user was also created with this cloud project user. Now let's go to the cloud formation and do it with the second VPC and EC2 template. So a new resource with this. Let's choose it with new resources. Choose second VPC and EC2. Next, we will go and we will choose maybe T2 small here. And then this is the key pair. This is ROPCOM key pair. So when you need to initialize your EC2 instances, you need a key pair so that you can access it from the SSH. So that is already created by me from as a ROPCOM key pair. So we keep it as a ROPCOM key pair. So let's name it this VPC EC2 project stack. So this is already done. Now, when we do the next, so this creation of the VPC EC2 stack has already started. Now, by the time it gets built up, let's go for the another template that we are going to use for S3 and Dynamo. So S3 will be used to store our product images. So what happens is like, so we have a seller and seller wants to sell something. So what it does is like it gets a form where he will upload his images, and while uploading the images on the S3, it will get a URL in the return, and that URL will be stored inside the seller table, that is a products table. So instead of storing the image as it is, we are storing the URL of the S3 URL that is for the image inside the this products table. So for that, we have created two tables here. So that is products table, and other one is the orders table, and third one is a S3 bucket. So this stores our images. So let's run this template also. So here we will give the order ID as the hash key element name, and we will put S3 Dynamo Cloud Project Stack as a stack name. So all the things are already done for this. So now we create a stack. Now let's go for the fourth template that we will be using. So this template is for SQS, Lambda, and SNS. So SQS, Lambda, and SNS, what happens in the background is like, suppose a customer wants to place an order. So when customer places an order, it goes to product API, and product API to the order API to the order when it stores the orders inside the Dynamodb table. So after it has stored, it will send a message. Yes, the new order has been placed, and you need to inform to the admin that the new order has been placed, and we can do some cloud analytics or something on that. For that purpose, we are using this flow. So after the saving inside the Dynamodb, order API will put the data inside the SQS, and then SQS will take the data to Lambda function, and Lambda function will run and put that code inside the put that information inside the SNS. So for this is a Lambda function. This is the order notification topic we have. This is the IAM roles that we have assigned for the Lambda, that you need to assume roles. This is the policy that we have created, that you can invoke the function list function and create event source mapping. These are the basic least privilege that we need to run this flow. And then there is a delete message get queue URL to access the SQS data, and this is related to the creating of the logs that we will be using, like the CloudWatch that we will be using to get the logs entry for the AWS Lambda functions. So let's upload this template also. So by the time we upload, so VPC Cloud has been created, S3 Dynamo has been created. So we can also go and check the check like if these things are working properly. So for the VPC part, so yes, so VPC, this is, so yeah, so this is the VPC that is created in the backend. So yeah, so this was created, this VPC was created. So let's check the subnets now. Yeah, so these are the subnets, 1, 2, 3. These all three are the public subnets. 4 and 5, these are the private subnets for the DynamoDB. So yes, these were created correctly. Then we have route tables. So yes, so these are the route tables that were created for the public table. And now we go and check the EC2. So yes, so these 3 EC2s were created for the for our 3 product API, seller API, and the React app. So these are running fine. Now we can go and check the S3 and Dynamo. And yes, a Dynamo. So this is Dynamo. Okay, let's go to tables. So yes, 2 tables were created, orders and products. And now these are the bucket that was recently created. Yeah. So this is the recent bucket that was created. Yeah, the outcome bucket that was created recently on 4th April current time. Okay. So you will be using to push the products here. Now let's go and do for the rest of the templates. Okay, so we were using the template file. So yes, we were using the SQS Lambda and SNS template. So this is a function name that we will be using. So let's keep it SQS, SNS, SQS Lambda, and SNS Cloud Project Stack. So this is by default. Now we will acknowledge it because of the roles. So it will work in the background. Now let's see the 5th template. That is the API gateway template that acts as the middleware for our project. So what happens in this API gateway is like so our React app is on the left side, suppose, and the APIs are on the right side. So API gateway acts as the middle layer between the React app, front-end app, and the backend app. So whenever there is a request coming, we will be using API gateway to filter that request. Now, why we are using API gateway? So what happens with API gateway is like, so if there are like so many requests coming, so we can use the rate limiter inside the API gateway that a particular person can make only these number of requests for a particular time being. So with what happens with that is like a person is not requesting too many resources at a go, and this will save us from the extra cost or the hacking. Plus, it also act as a reverse proxy for our system, and plus as a load balancer, like how we need to scale our application. So that, and here we have created the API gateway for that. So these actions are for the logs that we will be creating. Plus, this is the API. This is the stage, that is a deployment stage that we will be using. These are the resources, create new product resource. These are the methods, individual methods that we'll be using. So basically we have 4 methods, I guess, 4 methods for this, like for storing the image, for creating a new product, for creating new order, and for the fetching the products. So these are the endpoints that we have created. So these endpoints will be automatically created with CloudFormation template inside the API gateway. So this is required because we don't want to filter any of the request headers that is coming. So what happens, like some of the request headers are gone if we don't write this code in between the requests. So we have make sure that all the request headers are going. Yeah, so by the time we do it, so let's see the SQS Lambda. So it is already deployed. So let's see. So this SQS Lambda has been created currently at this time. So this is a SQS, and let's go for the Lambda function, and then go for the SNS. Okay. Yeah. So this is the order detail function that has been created. Now this is a simple notification service that is also created. So this is a topic. Okay. This topic, and there's a subscription. This is my email ID. I'm acting as an admin for this SNS. So a confirmation is pending at my side. So let's confirm it so that I'm subscribed to this particular topic. So when I go and open my Gmail, so yes, here is a notification to confirm that you have been chosen to subscribe to topic. So when I confirm this subscription, so okay, subscription is paid. Let's see what happens. Okay, so let's resubscribe to the orders. Okay, and this, yeah, SQS is added. Okay. Let's see and see if we can resubscribe to this orders. Okay, so actually there is a pending confirmation at my end. So let's see. Okay, so this was audio I created. So I have sent the notification again. Let's see if we can resubscribe it again. Yeah, so we have received the notification. Yeah, so this time it is confirmed. So it was a backlog. So that was a backlog message that we saw. So now it's starting to subscribe, and when we refresh it, let's see, and let's refresh it and see if it is confirmed. Yeah. So this email, now my email has been confirmed. So whenever I received, there is order placed, I will receive a order in my email. Okay, so let's go for the Lambda function. So this is already triggered, and let's set destination as SNS as our topic. So we will send this email on success and save. So yes, so there's SQS order trace function, and this is SNS that will be called at the backend. Now, by the time, let's upload the API gateway template also, and let's see what happens with it. So API gateway template is now going to upload. And so one thing I need to tell you that when we do the next, so we get this VPC EC2 cloud project stack. Why we are getting this as parameters? Because when we created the VPC EC2 stack, so we output three IPs, and one was related to the React app, second was to the product app, and third was related to the seller app. So this public IP2 and public IP3 will be used to deploy the particular APIs to their when the request come to API gateway. So seller will go to this part, products will go to the orders will go to this part. So in the template we have orders already set here. So yes, so instance stack name will get this data from the VPC EC2 stack output. So yeah, so this is the VPC EC2 cloud project stack, and we will get our output from here whenever we have created the VPC EC2 stack. So this is the output that we are getting. So that's the reason we are getting this VPC EC2 stack. So output of this stack will be used as input for the current stack that we are creating. So let's write it API gateway cloud project stack. Now we acknowledge it. Let's wait for the API gateway to set up. So these are the CloudFormation templates that I am talking about. So also you have seen like we have like done all the deployment from the start to end using the CloudFormation template without any manual setup. So when after this setup, my peer will show you how we will use this infrastructure to communicate through the app from one end, from the front end to the back end. So once we are done with the deployment, then we will showcase that video. We will add that video into this video. So let's see if our infrastructure is set up. Yeah, it is still creating. So let's see. Yeah, so creation has been done. Now let's go to API gateway. Let's close these tabs so that doesn't disturb us. Yeah. So this is the API gateway that has been created for the sellers and customer requests. Yes, so these are the 4 endpoints that I was talking about. So see, create new order. So this will automatically pick this HTTPS 35.174. So let's see how it comes from here. So yes, this 35, this is the output used for the customers for the ordering. So yes, this has been picked correctly here. Now this should have, the second API should have this 125. So let's see if that, yes. So this 125 is for the second type of request. That is, these requests are used by the for uploading the products or fetching the products, and this API is used for creating the new orders or going for the orders. So this is all about the CloudFormation templates that we have used. And in the next video, we will be talking about how our infrastructure works and how our request is going from one point to the other, where we will be showing all the components that are being used in our request. Thank you so much for this.
So hello, Professor. So in the second part of our video, what we are going to do is we are going to explain how our code for our application is working. So as we have worked upon creating an e-commerce website, so we have like targeted a few features, mainly the for the seller's perspective, we have made sure like the seller is able to add the products. And at the same time, a user who is visiting our application, he can actually go ahead and add the products to the cart, and later on, then while he makes the payment for the purchase, the order gets placed, and he gets the notifications as well. So coming to the, what are the main features for our application? So first of all, like we have created our application in the front end is in the React, and the backend we have done through the help of Node.js. So this is about the technologies that we have used. Secondly, like once we visit our website, a seller first of all has to log into the website. So this is the page that we have created for the login. Here we have like implemented few of the the field validations are there in this code, and then we went ahead and we just asked from the user their inputs, and once the user presses the button, the email gets validated. The email and the credentials get validated. Once those are matched with the values that we have in our database, he gets the access to our portal. So then there is seller page that we have created, in which this we have mentioned few of the fields, like the seller has to like provide the product name, product service, which sort of service he wants to go for, whether he wants to add a product, and whether he wants to update a product. But for the update feature that we will be working on in the later stage. But for now, we have worked on the add product. We are targeted for the user, the seller, he can add the product, and then he can mention the brand of the product, the quantity, what is the inventory, how much quantity is available, then the price of the product, and then the image, whichever image he wants to upload for the specific product. And once he clicks on submit, corresponding backend codes get hit, and the image gets stored in the S3 bucket. And finally, there is the submit product details. So once the seller hits on this button, a new product gets created in the Dynamodb with its image URL, which comes from the S3, gets stored there. So coming to the products display, we have created this page to display the products, whichever products that we create. So this generates a products list, and this gets displayed in this page. So this is the this generates a card element, and this actually creates the array of the cards, and which gets displayed on the products page. So all these details are coming from the API, this endpoint API v1 products, which comes from here, product controller, and which sends a get request to our API gateway, and API gateway in terms calls the seller API and fetches the products from the Dynamodb. Okay, so this is all about the products, and then we have actually implemented checkout. In the checkout, we have performed we have tried to implement our checkout feature with the Stripe payment. So whenever the user has the products present in his cart, he has the option for placing the order. When he clicks on placing the order, he gets redirected to the Stripe payment page, where he has to provide few test card details for now. And once the order gets placed, he gets redirected to the order place page. Here we have made sure a call is made to the create order API that we have created, which in terms calls which again calls the API gateway. There is a post call made, and the data for the order is then sent to the API gateway, and which goes to the order API that we have created in one of the EC2 instances, and which then calls the Dynamodb and stores our product the order data. So this is all about our application. And for the seller API endpoints, better would be explained by Harpreet. So over to you, Harpreet.
And all the TAs. So let me start by sharing my screen. Yeah, so hi Professor and all the TAs. Now I will be sharing my screen and explaining all the seller API. Okay, to start with, this is my seller controller, which is called using the seller route. In the seller route, all the endpoints in the seller API, which seller API has been defined. There are mainly 3 endpoints. The first endpoint is for you creating a new product. The second endpoint is for storing the images in the S3, and the third endpoint is used for fetching all the products from the Dynamodb. So coming to the functions which are called using these endpoints, they are present in the seller controller. In the seller controller, all the functions have been defined. To start with, the first function is the store products. In using this function, all the products data that is submitted by the seller on the form is comes all the data comes in this function. Then it is processed using this all the stored, and later it's sent to the Dynamo. First is sent to the S3. S3, for which the function is called store image. In the store image part, the S3, the image which is uploaded by the seller is first stored in the S3 bucket, and all the data related to the S3 bucket is given in the param section, like the bucket name, the key. Here the key is the primary key of the key is the name of the file which is being stored, and body consists of the file. Now we use the function s3.upload, in which makes a call to the S3 bucket and sends the image to that. In return, the S3 gives us the URL of the image. Now this URL, along with all the product information which we can see in this code, is stored in the Dynamodb. For the Dynamodb, the fields which we required was the table name, which you can see here, and all the params related to the like product information, and image URL is stored in the item tag, which is present inside the params. Now this params is sent to the Dynamodb using the function .line.put. After we call this function, the data is stored inside the Dynamodb. This is used for creating a new product. Now coming to the function fetch products. Now in the function fetch all products, what happen is we provide the for fetching all the products from the Dynamodb, we need to provide the function, the primary key which is used to identify a particular item. So we provide all the primary keys of all the items stored in the Dynamodb, and then we fetch one by one using the call .line.get. After we get all the product items, we store it in the array, and it is passed to the endpoint which calls this endpoint, which is done by the order API, and then it is displayed on the web page. Also, we have implemented the secret manager. As you can see in the secret manager, we have stored our SS key and secret SS key, which we get here, and it is used to access all the S3 buckets and Dynamodb. That's all from my side. Explain the seller API. Thank you.
Hi. So in the end, I would like to just explain one more thing. Okay. So I just want to explain one more thing, like how these APIs, the three APIs that the application is using, how they are deployed, and how our where our front end is deployed. So our front end application is actually the React application that is being served by our backend. So our backend is the one that serves our static React application from here. And all these routes contain like the payment route, the products route, the seller route. So these corresponds to the APIs that we have created in the separate EC2 instances. So mainly we have like seller API and the order API. Those are being deployed on two separate EC2 instances. And this whole our front end application, the React application, is being hosted on the separate EC2 instance. So the main thing, like when the customer contacts or reaches out to our website, so he directly faces the front end application, and whatever the services he requests, either whether he is a seller or maybe a customer, whatever services he utilize, the corresponding requests are made to the seller or maybe the order API, and they get satisfied or fulfilled with the help of those API calls. So that's how our application is working. So thank you. So in this part, I'll just mention like how we have actually deployed our APIs, our services on our front-end application on the cloud. So what we have for now used up is we have created our private repos on the GitHub, and directly we have pulled the repo content to our EC2 instance, and there we have set up the environment, and we have pulled the code from here itself and deployed our code on the EC2 servers. So similarly, like we have also used PM2 as a package, so that our application is always up and running, even though the server restarts. The PM2 package actually goes ahead and just like launches our application. So these are the two, like this is my order API that I have created, and similarly, this is the code for our front-end application that was deployed. And similarly, we have a repo for the seller API. So as our application grows, our plan is to leave this type of deployment way and move ahead with the AWS code commit. And we'll follow the continuous integration in our application. And this is all about our future plans. And thank you for letting me share how we actually deployed our code to the cloud platform. Thank you. Okay, so now I'll explain more on how our Lambda function is working. Just a second. So yeah, so in this, I'll just explain to you guys like what is the importance of our Lambda function and how it is getting triggered, and what is the use case for this service in our whole architecture. So whenever the order API is called, an order gets placed in the Dynamodb, a record gets generated there, and whenever the record gets generated, that the order table that is in the Dynamodb, an SQS message is generated, and at the same time, this SQS message which gets generated, it triggers the Lambda function, and Lambda function in terms like processes the information that is that was provided by the SQS message, and extracts the valuable content from it, and then sends SQS notification to the subscribed participants, and who have actually gone and subscribed to the specific topic that we have placed for the Amazon SNS. So we have written the logic for the Amazon Lambda in the Node.js itself, and here you can see we have tried to extract the data, specific data from the that we have received from the SQS message. And once we have the data, we have set up the data, set up the params, in which we have actually later on sent to published through the SNS publish function, and which gets published, and the subscribed users get a notification around it. So this is how our Lambda function is working, and how it is related to the SQS and SNS service. So this is our main web application that we have worked on. This is our e-commerce application, and the main feature would be around. So I'll start with what is the main feature for a seller. So whenever the seller visits this application, you just have to go ahead and do some normal like the security validation, like where he has to provide his email ID and username, and once he clicks on login, so the validations in the backend happen, and he gets access based on that. So now he has the option to add the product. So let's suppose I just go ahead and mention mention the product name as Racket, and it could be from Nike. So I'll place it as Nike. And number of products, let's suppose that 19 products are available. The quantity of the product is available with him, and the product price would be like, let's suppose $60. So now this button is the one like which helps you to add the image. So yeah, so I just go ahead and click on the image. So image is there. I have the moment I click on the submit image, so an image gets published to the S3, and the link is then with us in the backend. The moment I submit here, so the products actually gets added to the all the products. Here you can see that our Racket product is added. So that's how like the order API is working. And so till here, like we have actually added our product, the product name, the brand name, the cost for the product, and here's the add to cart button. So whenever a user comes and visit our website, he first of all have to like add some products in their cart. Let's suppose we add, let's go with Racket itself, a Racket, maybe the shoes. And then user has to like click on the cart button. So here you can see the Racket and the shoes are added to our cart. So currently there is one quantity. If the user wants to add like more, what they can do is just click here again, and the quantity gets added, and correspondingly the amount is also updated on the front-end application. So yeah, so then the user has to click on checkout, and he has to fill some sort of basic details. So let's go and say, and then here is the street address, okay, something like that. And here, state, and then here's the code. I'm just providing some random data. So currently we only have one option for payment, that is the credit and debit card, but later on we are planning to add few more payment methods to it. So the moment the user is done with filling all those details, he has to just place the order. So the user gets redirected to the Stripe payment page, where he can see all the products that he has selected, and correspondingly, like you can see the shipping details, shipping cost, EST, and all gets calculated. So now I am just so as we are using the dummy test account, I'm using the test account like card and its credentials. So yeah, so here I just fill all the details and I just click on pay. So it gets like verified from the backend, and yeah, here you can see like the order gets placed. So this is all about the UI and the flow of our application so far. Now I'll go ahead and just show it to you like how in the backend it is actually working. So in terms of services that were used. So let's go first of all to the Dynamodb. So in Dynamodb, like we have two tables created. One is for the order and one is for the product. So as we went, first of all, went ahead with the product flow because we triggered the seller API. I'll just show to you guys like the product table. Here in the product table, here you can see like I have tried to add one of the product which was from the Nike brand, and here in the products table, just a second, I'll just show it to you guys. So here, like once I visit the products table, I just have to refresh this, and here you can see where is it? So it's here. here you can see like in the front end, I have added like 19 table, 19 is the product quantity. This is the product price, and here's the brand. So all the details get saved here, and then this and similarly like the corresponding image is also stored in the S3, and like S3 link is provided to us here, which we can easily see like whenever we refresh, even though we refresh, the products data gets fetched from here and displayed to the user. So this is how like the data is getting stored in DynamoDB and DynamoDB tables, and then there is the second order table which is with us, and in this like the orders data is getting stored. So if you see, these are all the records that were generated, and coming to the record that was just now added. Let me just go and see which record was added right now. So I guess like this was the amount of this was the product. So these are the product details that I have added. And here you can see like I went for 2 rackets, and the corresponding image URL was also stored, and the quantity of that product and what was the price. And similarly, the user shipping information is stored. This was the total amount, and this is the paid date. So paid date is captured the moment the user places the product. The paid date gets added automatically. This is handled in the backend code from the backend code that we have written in the node. So this is all about the DynamoDB tables that we are handling through both the services that we have created, the order API and the seller API. And moving ahead, I would like to show to you guys our second service, which is so the second service that I would like to share that is directly related to services that we are working on. That is the seller and the order API. So whenever the seller tries to add a product, like the image for that product is getting stored here in the S3 bucket. So here you might be able to see, just a second, so here's the racket that we have stored, and this is the timestamp for that, and the racket image got stored, and similarly the link for this this racket image is stored in the DynamoDB. So this is all about the S3 bucket. And moving ahead, the next service that is directly linked to our application is the API gateway. Just a second. Just a second. Yeah. So API gateway. Okay. So this is the API gateway that we have created, and these are the 4 API endpoints that we have created. So out of which, like only the create order endpoint is taking care, which is part of the order API, is one of the container, and these 3 are in one of the container, which are basically and comes under the seller API. So these are some of the endpoints that we have created. So as you can see, like integration request, under integration request, you can see this is the URL that maps the API endpoint. So this is the API gateways endpoint here, which maps to the endpoint of our EC2 instance here. Here you can see. So these are all the API endpoints that we have generated, and we have actually deployed these on the API gateway. And correspondingly, our front-end application is actually trying to hit these URLs which got deployed. And in terms like this, these URLs are redirecting those requests to the corresponding services. So this is how our API gateway is actually working. And moving to the SQS, Amazon SQS, just a second. So this is the Amazon SQS that we have created, which is actually generating a message whenever a new order is getting placed. So coming here, this is the Lambda trigger that we have created. So our Lambda is getting triggered with the help of, with the message that were generated here. And so these are the messages. This is where we actually receive send and receive our message. And just a second here. So this is where we get the information whenever a message is in the flight or whenever a new message is available. We get the information from here, from this dashboard. Then coming to the Amazon CloudWatch. From the Amazon CloudWatch, we can actually view the logs whenever a new Lambda function is getting triggered. So these are the logs getting generated. We are also keeping the record of the logs. So this is all about the services that are the main services that are getting used while running our application. And this is all about it. And one more thing like that I would also like to mention is as we have subscribed to the SNS TalkTech. I'll just go ahead, SNS, yeah, here. So here you might see like there are 4 subscriptions there. So these are, we have added our email IDs. So whenever the order gets placed, the SQS message which gets processed by the Lambda, a notification is triggered and we receive a notification message. So here you can see I have received a message. So these were the details that I have received. So you can see like 12 minutes ago, a message was sent to us. So each one of the subscribed users will receive similar message. So here the order ID, the total amount, shipping, the first name, so last name of the user, and their email ID and address. So, and this is the order ID which we can use to track the order of the specific user. So this is all about our project. And yeah, thank you guys.